Okay, Unit 6, Lesson 6, you are distinguishing between two types of situations. So 6.1, it wants to know which equation doesn't belong. So first I want you to look at the equations and then decide which one does not belong and explain why you think that one doesn't belong. Okay, so we have 4 times x plus 3 equals 9. So when I compare it with the other 3 equations, one thing that I noticed was that it was the only equation with parentheses. So it's the only one with parentheses. Okay, then I have 4 times x plus 12. They all have multiplication in them. They all have addition. And they all equal 9. But I did notice that this one uses the multiplication symbol instead of using the side-by-side method. Okay, then I have 4 plus 3x equals 9. So this is the only one that would have 3x. So I could say that it's the only one with 3x. And it's also the only one that is not equivalent. So it's not equivalent to the other 3. And then I could also think about what my solutions could be. So I know 12 plus 4 times x has to give me 9. And I know that if I'm adding 12 to something and end up at 9, then that means I was in the negatives. So this x would have to be a negative. See, we have the same thing here because it's the exact same equation. So that means x represents a negative number. And then same thing above. So I need x plus 3 to equal a number that when I multiply by 4, I would get 9. So I know if x was 0, then that would be 4 times 3 equals 9, which would not be true. So that tells me that my x has to be less than 0. So x is also a negative number for this equation. Whereas if I go back to this one, 4 plus 3 times something would give me 9. Well, if x was 0, then that would leave me with 4 plus 0 equals 9, which is not true. I need it to be a little bit larger. Or I could say that if x was 1, so 3 times 1 is 3, and 4 plus 3 is not quite 9, so I know that x has to be a number larger than 1. So it's the only one where x is a positive number. Okay, look at 6.3. So we have 2 diagrams and 2 stories. On number 1, it wants to know which diagram goes with which story. So for story 1, it says Lynn had 90 flyers to hang up around the school. She gave 12 flyers to each of the 3 volunteers, and then she took the remaining flyers and divided them up equally among the 3 volunteers. On story 2, Lynn had 90 flyers to hang up around the school. After giving the same number of flyers to each of the 3 volunteers, she had 12 left to hang up by herself. So which diagram goes with which story? So diagram A goes with which story? Story 2. And diagram B goes with which story? That would be story 1. Okay, on number 2, it says in each diagram, what part of the story does the variable represent? So for diagram A, my X represents what? So I know that the 12 is how much she hung up herself. And then I know she gave the same amount of flowers to 3 volunteers. So then X represents the number of flowers that she gave to each volunteer. Okay, for diagram B, I have 3 equal boxes and Y plus 12 in each of those boxes, which was related to story 1, which said that Lynn had 90 flowers to hang up around the school. She gave 12 flowers to each of the 3 volunteers. Then she took the remaining flowers and divided them equally among the 3 volunteers. So Y represents the remaining flowers that she gave to each volunteer. Okay, number 3 wants you to write an equation corresponding to each story. So let's look at story 1. We have Lynn had 90 flowers to hang up around the school. She gave 12 flowers to each of the 3 volunteers, and then she took the remaining flowers and divided them up equally between the 3 volunteers. So our story 1 matched with diagram B. So if she gave each volunteer 12 flowers and then gave them each the same amount on top of that, then I know that there were 3 total volunteers and they each received the same amount, because I had 3 groups of Y plus 12. So for story 1, that tells me that I have 3 groups of Y plus 12, and that equals 90. For story 2, which went with diagram A, Lynn had 90 flowers to hang up. She gave the same number of flowers to each of the 3 volunteers. Then she had 12 left to hang up by herself. So I have 3 groups of X plus an additional 12, and it equals 90. Okay, and then number 4 just wants you to find the value of the variable in the story. So for story 1, we had 3, Y plus 12. That equaled 90. And then for story 2, our equation was 3x plus 12 equals 90. Okay, so let's look at the first equation. So I know 3 times y plus 12 equals 90, because I had 3 equal groups of y plus 12. And I know those 3 equal groups have to equal 90. So it would help to figure out what each group represents. And I could do that by dividing by 3. So 3 divided by 3 is 1. And 1 times y plus 12 is just y plus 12. And then 90 divided by 3 is 30. So now I know that there are 30 in each box, or each volunteer has 30 total flowers. They were originally given 12. So to figure out how much they were given after that, I could subtract 12. And then that tells me that y equals 30 minus 12, which is 18. So she gave each volunteer an additional 18 flowers. Okay, for story 2, so I had 3x plus 12 equals 90. So now I don't have every part being an equal, so I probably don't want to start out with division. Instead, I only have 3 equal parts, and so I want to know what those equal parts equal. But I have a 12 that I can't just divide 90 by 3, because 12 makes up part of 90. So first I want to subtract 12 to figure out what my 3 equal parts add up to. So now I know my 3 equal parts have to equal 78. So now I can figure out what each of those represent. So if I divide by 3, that's going to tell me that each x equals 26. So that tells me that each volunteer had 26 flyers. And then Lynn had to hang 12 up by herself. So look at the summary. We have, after adding 8 students to each of the 6 same size teams, there were 72 students altogether. So that tells me I had 6 teams that were the same. So I had team 1, team 2, team 3, team 4, team 5, team 6, where X represents the number of players on each of those teams. And then I added 8 to each team. So team 1, I added 8 to. Team 2, I added 8. Added 8 to team 3. Added 8 to team 4, to team 5, and to team 6. So now each of those teams is made up of the original number of players plus 8. And I have 6 of these teams. So I have 6 groups of that, which is a total of 72 students. Then on number 2, it says, after adding an 8-pound box of tennis rackets to a crate with 6 identical boxes of ping pong paddles, the crate weighed 72 pounds. So now I still have 6 identical boxes of ping pong paddles, and I don't know what those weigh. So there's 1 box, 2, 3, 4, 5, 6. So I know all 6 of those weigh the same amount. And then I added 1 box of tennis rackets that weigh 8 pounds. And then all together that they weigh 72 pounds. So now I only have how many identical groups? 1, 2, 3, 4, 5, 6. And then I have an additional group, but it's not identical. So I can simplify my 6 boxes of ping pong paddles since they weigh the same. So I have 6 groups of X, but then I have a box that weighs 8 pounds to give me a total of 72 pounds. So even though I'm using the same numbers and they equal the same thing for these 2 situations, they're different because I have 2 different equations. So my X does not represent the same number for both of these situations. So it's really important to pay really close attention to the situation that you're given so that you can determine what your equation for that situation would be.